another trigonometry problem, which I don't want to do the whole problem with you folks. You can do it. I just want to highlight the important parts. And that is this cosine of 90 minus a. I think let's do this one. Okay, we know that this has two ideas behind it, the quadrant plus the co-ratio that we want to work with. Okay, so the 90 plus and the 90 minus we've got. Now, what is a minus a? There's no such a thing as a negative angle. Okay, the negative in front of the a just indicates direction. So instead of going anti-clockwise, we're going clockwise. So for minus a, we are in the fourth quadrant. That is where positive a would have been. The negative indicates we're doing the opposite direction, but the magnitude of the angle is still the same. This one is beautiful. Now, you're not going to play around with those. We want to know where's a minus 360. Now, just think about it logically. There's a, because it's a positive. If I subtract 360, I change direction. I take 360 away, I'm at the same place. If that was a minus 180, I would say, oh, okay, it's a positive a, which lies in the first, and I would minus 180 from that to lie in quadrant number 3. So just use your common sense. You're not going to do unnecessary work here. We are given this thing that we need to simplify. Okay, so let's have a look. The first one lies in quadrant, as we saw here, in quadrant number 1. So it simplifies as the sine of a. The cos of 90 plus a is in the second quadrant, where cosine is in a bracket negative. Cosine, because of that 90, changes to the sine of a. Okay, in the denominator, the same thing. This time around, we're in the first quadrant, okay? Cosine in the first quadrant is positive, but it changes to the sine of a if it goes into the first quadrant, because of that 90 degrees. The tan of minus a we saw over here is in the fourth quadrant, so that becomes minus the tan of a. So far we can say goodbye to those two signs, and we can change the minuses to a positive because there's two of them. And let's see what happens now. We have the sine of a divided by, now here I'm forced to use my quotient identity, sine a over the cos of a. Okay, now what does this mean? Well, this means I've got a complex fraction. If I have a complex fraction, I multiply both the denominator and the numerator with the LCD of the fraction, which in this case is cos a. So I times the top with cos a, I multiply the denominator with cosine of a. I keep on thinking sine and cos. So I multiply with cosine of a there. Those two go away. Then I'm left with sine over sine, which is 1, multiplied by cos a. So in fact, I'm left with the cosine of a.